Okay, so today we are going to look at addressing modes of 8085 microprocessor. What does addressing mode signify? They tell you that where is the data, where is the location of the data. Okay, so in generally speaking, addressing modes are going to answer one simple question: where is the data? Right, so there are 5 addressing modes. We are having several instructions in each addressing mode. We're going to look all the instructions when we look at instruction set. Right now we're just going to focus on different addressing mode. So first addressing mode is going to be immediate addressing. What happens in immediate addressing is, just after the opcode is located, just after the memory location of the opcode, next memory location data is going to be stored. For example, suppose we've got an instruction MVIA 23H. So what happens in immediate addressing is, we already know that all the opcodes, all the instructions are going to be saved in the memory. So see, this is a 2-byte instruction. This constitutes of 1 byte and this data is 1 byte. So what happens is, suppose at memory location 2070, this MVIA was stored, MVIA. In the next immediate location, next memory location, that is 2071 only, this 23 is going to be stored. So what do we get is, this data is stored in immediate memory location. That is why this is known as immediate addressing mode. Fine. When you decode this opcode, when you're trying to decode this opcode MVIA, the microprocessor knows that some data has to be loaded into the accumulator, some data has to be loaded in the register A. Then the microprocessor is going to make this question, where is the data? So in immediate addressing, the data is going to be located in the immediate memory location, immediate next location, which is 2071. So here is the data. Now next addressing mode is, see, there are a number of instructions in each addressing mode. We are going to look at them separately. Right now we're just discussing different types of addressing mode. Next addressing mode is going to be direct addressing. What happens in direct addressing is, see here, the data was located in immediate next memory location. What happens in direct addressing is, you are giving the memory location of the data, address of the data directly in the instruction. For example, you're giving an instruction LDA 3070H. So what have you given? Now we have given the memory address of the data. This is the address of the data. So in this addressing mode, we give the address of the data directly. What happens now, whenever LDA is decoded, whenever you're going to give this opcode LDA, we know that accumulator has to be loaded, but with what data, where is the data? This is the address of the data. So what happens, we'll go to this address in the memory, extract the data and load the accumulator. Suppose at 3070 1A was stored. This was the data. So after execution of this instruction, after reaching this memory location, we're going to extract this data 1A and accumulator is going to be loaded with data 1A. So in direct addressing mode, we are giving the address of the data directly. Then next addressing mode is going to be indirect addressing mode. Next mode is going to be indirect addressing. What happens in indirect addressing is, here also we're not giving if the data is not located in the immediate location, we're not giving the data address directly. We're not giving the memory location of the data directly. From some place the memory location has to be identified. For example, suppose you write this instruction MOV A, M, which means that load A with the data located in memory. Now where do you get this memory location from? This memory location is indicated by HL pair. Suppose HL pair constituted a value 4050. This means that whatever value HL pair points to, this is the required memory location, this is the required memory address where our data is stored. So what happens is, this HL pair will give some value. You reach this value in the memory, extract the data, and we are going to load A with contents of 4050. Contents of this memory location. A is going to be loaded with contents of 4050. So we are not given the address of the data directly. We have to first extract the address of the data, then we reach that address and extract the data and load the register A with that data. This is known as indirect addressing mode. Then there is one more addressing, which is register indirect addressing. So what is going to happen here is, here we are not going to access the memory, okay. Here the source and the destination both are going to lie in the microprocessor only. There is going to be a source register and there is going to be a destination register. You are going to pick up the data from one of the registers and move it to another register. For example, MOV B, E. See here, this register B is the destination, this is the source, right? So what happens is, suppose E was holding the value B3 and B were holding the value, initially it was holding a value CE. Now what happens after execution of this instruction is, contents of E are not going to change, okay. Contents of E are going to be unchanged, unaltered. But what happens to contents of B? They are going to be overwritten with contents of E. Copying is going to take place. So this is register indirect addressing. See, we are not accessing memory here. Both of these registers are lying inside the microprocessor only. So copying takes place inside the microprocessor. This is only going to have 4 T states, okay, because we are not accessing memory. Then there is one more last addressing mode, which is implicit addressing. See, in this addressing mode, actually no register is going to be touched, okay. We are not going to perform any functions with the register. No instruction is given. It is having instructions such as STC, CMA, RRC. We are going to learn about them, but for now you can see, what does this instruction do? It is set carry. So we are having a flag register basically, in which there is a carry flag. After execution of this instruction, this carry flag will become 1, just that. This is complement accumulator. So what happens is, simply all the contents of the accumulator are going to be complemented after execution of this instruction. So these are the 5 addressing modes that you need to know. There are another instructions also. In each of these addressing modes, we are going to look at them separately when we study the instruction set.